So my name is Michael Yuan, and so we've heard from Jim that open source AI has won. And we've also heard from Chris that their new certification program for running AI in the cloud. We also heard from Bill, there's new products, and there's many ways to run open source AIs in the cloud. However, the question has to be asked, why is today most cloud native applications are treating the large language model or AI models as second-class citizens, meaning we are running them inside cars, although they are open, but behind some kind of obscure API servers or API gateways, and not integrating them into our main application logic. So this is the point I want to discuss in this keynote, how to make them the first-class citizen. And so a little bit about myself. So I'm a maintainer of the WasmEdge project. I contributed to a bunch of open source projects as well, so not that important. So I think the reason we run AI applications almost as an afterthought in our cloud-native applications is because currently the AI runtime model is very incompatible with the cloud model, because what enables the cloud is the portability of the workload of the payload, right? Because as one of the famous saying has gone, that's cloud is just other people's computer. So the whole cloud development deployment paradigm is that I write application on my own computer, but I'm going to deploy it on a computer that I've never seen. And other people are going to move it across different computers they have never seen either. So this is the whole idea of portable runtime containers and DevOps and things like that. However, AI breaks this mold. We all still remember there's just one CPU, the x86 CPU. There's two operating systems, the Windows and Linux operating systems. But today, in AI, we have the hardware has this is an incomplete list. There's just so many. Every cloud companies now have their own proprietary hardware to run AI workloads. And you multiply this by a number of drivers. So for instance, there's CUDA, different versions of CUDA. Apple just announced the Metal 4, which is incompatible with the Metal 3 on the Mac. And they also have MLX, right? So even on one single hardware platform, you have multiple driver software. And then you have incompatible runtimes. You have PyTorch, you have llama.cpp, you have VLM, you have SGLang, and you have all that. So for applications that build on top of that, portability has again become a huge problem. We thought we have solved this problem almost 20 years ago first with Java, then with Docker. But now this problem has become front and center again. We cannot assume the application we build would be portable. So the solution people come up with is an AI sidecar, right? So we have the OpenAI, and they are provided as an API service. So why don't we just build our application logic in our main application using whatever programming language you are comfortable with, and interact with the AI as if they are hiding behind some, like I said, hiding behind some obscure wall. We interact with it through APIs, right? It's okay for, I think, for many applications so far, because you don't need very low latency, and the AI logic is not tightly integrated in your application. You're basically treating it like a chatbot, right? You ask a question and get some answers. So this, I would say, it would be the first generation of AI native applications. However, this is what my desk look like, in my office. We are getting into the place, especially here in China. We are so close to the manufacturing capital of the world, which is Shenzhen. There's so many devices that are being produced that needs to interact with AI, cloud-based AI applications in a manner that is performance critical. So for instance, if I build a conversation agent or a teaching agent or a customer service agent, I need to run AI models. They are written at the bottom. It's the VAD, the voice activity detection models, the ASR, which typically the voice-to-text models like Whisper, the large language models. We also know what that is. Large language models might make MCP or tool calls to look up databases. And after that, we use TTS to synthesize it back to voice. The entire thing has to happen within 100 milliseconds in order for the user to feel that he's talking to an intelligent being, instead of I'm sitting there waiting for three seconds before or worse, 10 seconds before the AI could even come back with something. So for new generation of applications, we would say that the sidecar model is very broken, because all the interaction you have to go with the sidecar. So is my next slide. So the sidecar shortcomings. The very first one is the HTTP API is super inefficient for many of the newer tasks demanded by the end user applications, right? The serialization, deserialization is very slow. Network latency is very high. Streaming is extremely hard through HTTP. And stateful inference is very complex because remember, your model and all the inference stack is behind the API wall that you have no control over, or you have very little control over. So in order to cache the prompt, so if you have a large prompt, 1 million tokens, 2 books in a prompt, I could put a whole book in a prompt, and you build the KV store first. So through the API, there's very little way for you to control or manipulate that. And the second even bigger problem is the primary or the business logic leaks into the sidecar because you need so much interaction between because AI model and the application. You end up writing, either have a very complex workflow in your primary application, or you try to manipulate what's inside of the sidecar, which sort of defeats the purpose of having an API wall behind it, right? So the sidecar model, in my opinion, has many shortcomings that would not be able to address a lot of the AI workloads problems that we see from our customers, right? So that goes to the answer, unexpected answer. So where is this compatibility or the portability level come from? Would that come from, say, the old days like Java or like containers? Our answer in the WasmEdge community, our answer is maybe Wasm is the answer. Maybe Wasm, like Java in the early days, that united all the CPUs and operating systems. Maybe we can have a new virtual machine or bytecode format that unites all the GPUs, provide GPU portabilities, and also runtimes on top of those GPUs. So Wasm has some, if you don't know, Wasm is basically like Java. But it's much lighter bytecode format, right? So it's provide abstraction over the hardware and software runtimes beneath it. So it has several features, so it's cross-platform, lightweight, and things like that. We have been doing that for a couple of years, so in WasmEdge in particular, we are using very large-scale AI inference. For instance, one of our, I would say, customer partner, Gaia Network, has over 600,000 machines. 600,000 machines, each has a GPU running inference using the WasmEdge project. We also have a company here it's called 5 Miles. It's a main business in the US. It uses WasmEdge to process over 500,000 videos per day. So they are user-generated video platform. So they use multiple AI models that tied together in a pipeline. So because those are almost semi-real-time audio-video processing using large language model, visual large language model, and things like that. So they really can't afford to put all those behind the API gateway on the sidecar, right? So I would say, is that the answer? I don't know. But there are some successful use cases. I guess that's the point I'm trying to make. And so one of the things that we do at WasmEdge, paradoxically, is that we are also one of our primary use cases is also providing API server, but it's no longer in the sidecar outside of the main application. It's become API server that's embedded in the application. Okay, so that subtle difference makes makes your application so much easier to do. So the API server that we build on the community built on LlamaEdge supports all the major OpenAI style endpoints. It's not just the large language model, the chat completion, but also the audio transcriptions, audio translations, audio speech, speech synthesis, and image generations, and things like that. And very importantly, it's portable across all major hardware and software platforms. Meaning that a single Wasm binary, you don't have to embed or link to a native binary anymore. You just use a single Wasm binary and you can copy it around using FTP, right? And it's very lightweight because people would argue the Python can do that too. I just have a regular Python application and copy it around. But the PyTorch Python image is 8 gigabytes wide, okay? So the Wasm application is 50 megabytes. So it's 3 orders of magnitude smaller, okay? So you can not only use WasmEdge as the embedded API server, which is what people do today, because most of the AI application today using API to interact with the model. So we are moving the API server from the sidecar into the main application logic itself. But I think going forward, what we would even more like to see is to use the abstract API provided by the WasmEdge directly. Not deal with CUDA or not deal with llama.cpp, APIs provided by them, but using the W3C standard called WasmEdge, and then directly interact with that through your Go application or Rust application or things like that. So bypass the whole API calling process. So yeah, I think that's my time's up. Thank you very much, and check out our project. Thank you.